Alright, y'all, try to improvise with me here. I'm trying to go over this so y'all can see it. Emmett's still sick, and I'm just not able to make it. On this first one, it says to divide and simplify. So I'm going to divide 48 divided by 3. And I'm improvising with my calculator here. So that's 16. And then x cubed divided by x to the first. 3 minus 2, that's x squared. And on the bottom, I'm left with the square root of y squared. So the square root of 16 is 4. Square root of x squared is x. Square root of y squared is y. On this next one, simplify. 250 divided by 2, that's 125. X to the 7th divided by x squared. 7 minus 2 is x to the 5th. And then y cubed divided by y to the first, that's y to the second. And then the cube root of 125 is 5. And then I can do power divided by index. So 5 divided by 3. Whoops. 3 goes into 5 once with 2 remaining. So 1x comes out and 2 x's remain in. And then 2 divided by 3 is not possible, so all 2 of the y's remain in. All right, on this bottom one here, 42. Reduce that fraction, 20 over 45, that reduces by 5, so that's 4. On the bottom, that's 9. The a's will reduce. This is a to the first, this is a to the second, so a to the first will be on the bottom. And then this is b to the first and b cubed, 3 minus 1, that'll be b squared on the bottom. So when I simplify this, the square root of 4, that's 2. The square root of 9, that's 3. The square root of b squared, that's b, but I can't take the square root of a because it's not a perfect square. Now, I do have to rationalize this denominator to get rid of that square root. So I'm going to multiply by the square root of a to make that a squared. So on the top, that'll be 2 square root of a. On the bottom, that'll be 3b square root a times square root of a is the square root of a squared. So that will be 2 square root of a over 3b square root of a squared will be a. All right, let's go on to 44. All right, so 44, you have to rationalize that denominator. 5/8 does not reduce. So I'm going to go ahead and look at my paper, which I don't have, so I'm doing this from memory here. 8 can be changed into the perfect square of 16. So I'm going to multiply by the square root of 2. And then x needs to be a perfect square so that it's divisible by 2. So this is like x to the first. And I want to make it x squared, so I'm going to multiply by 1 more x. So on the bottom, that'll be the square root of 16x squared. 8 times 2 is 16, x times x is x squared. On the top, 5 times 2x is 10x. So on the bottom, the square root of 16 is 4. Square root of x squared is x. On the top, 10 has no perfect squares that go in there, and you can't do 1 divided by 2. So it just stays the square root of 10x. And that would be as much as it could be simplified. I got rid of the root. All right, on 46, I need to get this root gone in the denominator. This does not reduce any, so I'm just going to separate it as the cube root of 5 over the cube root of 3x. Now, looking at your perfect cubes column, 3 needs to be changed into a perfect cube. Can't be changed into 8, and it can be changed into 27 by multiplying it by 9. So I'm going to multiply by the cube root of 9. This is x to the first, but I want it to be 3 so that I can cube root it, so I need 2 more x's. So on the bottom, that'll become the cube root of 3 times 9, that's 27. X times x squared is x cubed. On the top, that'll be the cube root of 5 times 9, that's 45 x squared. So on the bottom there, the cube root of 27 is 3. The cube root of x cubed is x. On the top, let's see if 45 reduces. Perfect cube, that could go in there. 27's a decimal, 8's a decimal, so that can't be reduced any. And then 2 divided by 3 is not option, so I just leave it on the top as is. All right, 48. This one has numbers out front, but you just reduce them like if they were the regular fraction 15/3. So 15/3 reduces to 5 on the top. And then 60 divided by 12. Use my calculator here. Make sure I reduce it right. Oh, 60 divided by 12. That's 5. So that's going to stay on the top there. And then x to the 5th divided by x to the 1st. That's x to the 4th. So nothing was left on the bottom. That makes it a lot easier. I don't know the square root of 5, but I do know that the square root of x squared, or x to the 4th, is x squared. And that's it. I didn't have to rationalize that denominator. And once again, I didn't have to rationalize because 60 divided by 12 was 5. X to the 5th divided by x to the 1st will stay on the top, so that's x to the 4th. And then square root of 5 can't be reduced, but the square root of x to the 4th is x squared. And then I just leave that other 5 under the root. All right, last one. All right, simplify 5/2, not an option. I can simplify these x's though. That x will stay on the top because that's where it's bigger. 4 minus 2, that's x squared. And then that 2 stay on the bottom there. And then y to the 1st and y cubed. Y cubed's on the bigger, so bigger is on the bottom. So it stays on the bottom. And 3 minus 1 is 2. All right, now I have to rationalize this denominator. I need to make this a perfect square. Luckily, the y is already a perfect square, so I don't have to change the y. But the 2 needs to become a perfect square, which would be 4. So I'm going to multiply by the square root of 2. So on the top, that'll be the square root of 5 times 2, so that's 10. And then x squared. On the bottom, 2 times 2, that's 4. And then I have y squared. All right, so let's simplify this bottom here. Square root of 4 is 2. The square root of y squared is y. On the top, 10, perfect square. 9 won't go in there, 4 won't go in there, so I'm just going to leave it as a 10, square root of 10. But the square root of x squared is x, so I can take that out of the root. No root left in the bottom, so I'm done. You are going to get a worksheet today. Only do the problems that are circled. You can work together with somebody, but make sure you're bouncing ideas off each other, not just copying, actually helping the person that you're working with. So you may want to choose, match up with somebody that's not really sure, with somebody that knows, so you all can actually help each other. All right, see you all Monday.